Hi, everyone, and welcome to today's Rancher Online Meetup. My name is Shannon Williams, and we're excited to have so many of you here today to learn about K3s, our new lightweight Kubernetes distribution. As is usually the case, I am joined today by my co-founder here at Rancher, Darren Shepard. Darren, are you there and online?
Yep, I'm here.
Awesome. Darren is joining us today from his hotel at Disneyland, where his kids are off having fun, and he's stuck in the room working on his demo, getting it all tuned, and I'm sure it'll go awesomely today.
On
Does it
hotel
always
Wi-Fi
does?
and everything.
Oh my goodness. Well, it looks like we have an enormous crew here with us today, which is great. I mentioned I'm Shannon. I'm one of the founders and the head of sales and marketing here at Rancher. You can follow me on Twitter. Darren is our chief architect and the architect behind Rancher and K3s. He is also on Twitter. We're both also on Slack and Zoom and email and anything else. I'm just Shannon at rancher.com if you ever need to get a hold of us to ask questions or need any help. But it's great to see everyone here. For those of you who are new to our monthly online meetups, Darren and I have been hosting this meetup now for like 2 years, at least 2 years, maybe 3 years. We've been running these things since at least 2016, and so it's these are always a lot of fun. They're pretty unique. A couple things about them. We really do try to treat it like a meetup and not a webinar. That means a whole bunch of things. First of all, we don't set a time for when these will end. We just start and go. We take your questions, we record the whole thing. It is all going to be posted on YouTube within a day or two. We post the slides up on SlideShare, so you shouldn't have any trouble getting them. The big thing is, this is your meetup. Your questions are really always welcome. There's a wonderful questions feature here in GoToWebinar that you can put in. We will try to respond to them. We will answer them. We will ask them out loud. The other big thing is we try to minimize the slides and demo a lot. So as usual, we'll be showing this. Today we'll be hands-on with K3s. Usually things go well. Occasionally we have little bits of problems. So if there are any issues with the demo, please be patient. Darren usually has some kind of fully baked souffle in the oven. So we'll hopefully be able to pull it together. If you're ever interested in watching another one of these recordings, we put these up on YouTube under the Rancher channel, and you can find a special playlist of online meetups and webinars where you can find all of our previous content. Usually we try to link to different sections so you can make your way through. You can see here most of these things run about 2 hours. So just to give you an idea, that's pretty typically how long we go, is two hours or so on this every month. We also welcome you to join the conversation on Twitter. We use the hashtag Rancher Meetup. You can meet each other. Please, if this is your first time, post a picture. Let us know who you are, where you're here, what made you decide to attend. If you're in some place watching or eating your lunch or eating your dinner. We've had people post from cars they were driving, listening to. So wherever you are, take a picture, post it, meet someone, and join the community. We love hearing from all of you and what you're trying to do. The other thing we've added is that we've now created a Slack channel for the online meetups. I think we created it as of the last one. So if you go to the Rancher users Slack, which is slack.rancher.io, if you haven't already joined it, you can go there. You can join the online meetup. If you just search Rancher Slack, you'll find it pretty easily. There's a hashtag online meetup group, and you can easily find us in there. So there you can talk to each other. It's recorded. It's a little easier sometimes to organize than Twitter. So with that, I'm excited to dive into today's content. I'll do a quick introduction of Rancher for those of you new to us, don't really know who Rancher is. I'll happy to quickly introduce our company and our products. Then we'll talk a little bit about why we built K3s and sort of the demand we've been seeing for a lightweight Kubernetes distro for the edge and also for a lot of other different use cases. Then Darren's going to dive into a little bit more of the details of K3s, how it was built, what we did, what we pulled out, how we packaged it to kind of get the size down. Darren will then demo it, and we'll show you it running in some different locations and how to set it up. It's pretty straightforward, and we'll wrap up with any remaining questions. So if your question, by the way, isn't being answered, it usually means we're about to cover that topic, or maybe the question's a little bit off the current topics, we'll probably circle around to it. But we do stay till the end, so usually we're here for quite a while after we stop presenting, and we're just taking questions, trying to answer them out loud or responding to them in the questions window. So if you have questions, fire away. With that though, I'll just give you a quick intro to who Rancher is. Rancher is a software company based in Cupertino, California. We are about 120 people, and we build basically open source container management software. Our most popular project is called Rancher. It's a centralized management plane for managing multiple Kubernetes clusters and applying a lot of the DevOps tooling necessary to consume those clusters, as well as the central operational capabilities for teams that have to manage lots of clusters. So we deal with questions like how to monitor the cluster health, how to connect it to your directory services, how to set global policies, apply them to clusters. And one of the things that makes Rancher really cool is it really manages any Kubernetes cluster. So we have our own distribution of Kubernetes called RKE that we can create and deploy anywhere. But we also manage Kubernetes that's been deployed however your organization gets it. So it's a hosted Kubernetes service from an existing cluster that someone's deployed. You can always import clusters, and then beyond that, we really service two teams: the IT organization that's building out kind of policies and plans for how Kubernetes should be consumed, and the DevOps teams that are actually using Kubernetes to run their application. So what's really fun is we bring together a lot of this ecosystem, things like Prometheus and Helm and all your networking and storage drivers and everything that you need to kind of build out Kubernetes is coupled inside of Rancher. So Rancher is really popular. It's used by 20,000 plus teams every day to manage their Kubernetes environment. So if you're looking for something like that, dive in. RKE is our distro of Kubernetes. It's a really lightweight installer. You're welcome to check out that. We broke that out more than a year ago. In fact, a lot of that, the K3s stuff, has actually come from that. Before I dive into K3s though, I did want to just kind of mention that this week we introduced another new open source project. So 2 weeks ago we introduced K3s. This week we introduced a project called Submariner. And Submariner is all about creating network connectivity between separate Kubernetes clusters. So when you have two Kubernetes clusters and you want to create a network that spans them both and allows for discovery of services like databases running maybe different components into different Kubernetes clusters, or if you want to have something like a service mesh span across multiple clusters, Submariner is sort of ideal for that. So it's an early stage project. You can learn all about it at submariner.io. We do a lot of, there's quite a bit of detail on the website about how we built this. You can find the details, as always, it's all open source. So feel free to jump over to GitHub and you can learn about a bit more there. Most importantly, we'll be running another online meetup actually next week, introducing Submariner. So if you're interested in this more, you can go to our website at justrancher.com/events and register for that, or just feel free to Slack me or something else if you can't find this. But I put the link here as well, so you should be able to find a little bit of information about that. So very cool project. We're not going to get into it today, but we'll be talking about it quite a bit next week. So with that, I want to talk about K3s and sort of introduce you to the idea of K3s. And really, at its core, K3s is all about, kind of taking the idea that Rancher has been promoting for a while, the idea that you're probably going to be running Kubernetes not in one giant cluster, but rather, running sort of a multi-cluster universe of Kubernetes, and to its sort of, fabulous extreme, where Kubernetes clusters are sprouting up just about everywhere, on the edge or, for individual applications. And to do that, there's a lot that we had to go through. But really, a lot of our inspiration did come from teams, that we were already working with, trying to put Kubernetes, take Kubernetes and run it outside the data center. And good examples of that have been pretty public. People like Chick-fil-A last year shared how they have been building Kubernetes clusters in each of their restaurants to manage all sorts of applications. The Targets talked about, kind of also last summer, the deployment of Kubernetes at retail scale, basically deploying a Kubernetes cluster to 1,800 stores to be able to to run applications there. But we had a really interesting story at KubeCon in China from Goldwind, one of the largest wind turbine companies in the world, about how in every deployment area where they have turbines, they're running Kubernetes to manage all sorts of different software. And that's really the reason that we're seeing this in a lot of ways, is that the concept of microservices, the ability to sort of put together lots of different software out at the edge to do especially analytics and potentially even operational control of systems, really makes a lot of sense when you start thinking of different systems working together and wanting to have more and more software collaborating, as opposed to it's not like I just want to run one embedded system that's going to do everything. Now, in a lot of ways, I'm running almost a data center like level application out in stores, because I'm monitoring all sorts of different things and doing analytics and then pushing back up data that has been manipulated. So we're seeing things like that that are driving the need for Kubernetes. And when you think about that complexity of those software, that's really what drove the need for for Kubernetes in these different locations. Yes, containers themselves are awesome. They give us a really good way to package up the code. They're consistent across all this different infrastructure. That certainly is part of why it's been valuable. But when you kind of dive into it, the areas I think that a lot of organizations we're talking to are excited about is actually on the operations side. The ability to easily do upgrades or replacement of containers, the ability to replace components very easily, the ability to have consistency across both what they're running in the data center, what they're testing on their laptop, and now what they're running on the edge. And obviously, this ecosystem that's developed around Kubernetes makes it very compelling, right? There's tons of monitoring and logging tools. Your CI platforms work really nicely, talking to Kubernetes API. There's management layers that can now manage multiple clusters and allow you to sort of apply global policies and deployments to them. In our last meetup, we talked about multi-cluster applications, where you could create a Helm-like application that could then deploy to potentially almost like a daemon set, but deployed to hundreds of clusters. So we're just seeing a lot of ecosystem that then now all of a sudden makes Kubernetes potentially a really good fit for these edge or other sort of lightweight deployments. And so we were seeing this demand really with just Rancher. Our journey kind of started with Rancher. We built Rancher to deploy Kubernetes anywhere, and part of that meant we could deploy and manage multiple clusters. So we saw a lot of interest from kind of early adopters of Kubernetes at the edge of using Rancher as a management plane to manage all of these clusters. And they were using Rancher's ability to create and deploy clusters. And as part of that, we, in working with them, we saw some opportunity to kind of split out the management plane from the actual distro. So last year, actually end of 2017, beginning of 2018, we actually pulled RKE out and enabled people to just use that and to do automation around deployment. And it did a lot of really nice stuff for kind of being able to label workers and nodes and have them automatically deploy Kubernetes and scale and be able to really script the deployment. Not that Rancher was the only way to deploy Kubernetes, tons of different ways, but this became something that became really popular with teams putting Kubernetes into cruise ships or satellite base stations. And we saw saw automakers using it in factories. So we saw a lot of these types of use cases with RKE. And the more we kind of dug into it, we realized that we still had a bunch of challenges with even the implementation we had today of RKE. Most of the Kubernetes distributions we ran across didn't support ARM, and this was clearly something we were getting demand for. RKE, for example, we hadn't spent the effort to go and port it to ARM, so we kind of had an opportunity to look at that challenge. We also found that just the overhead of Kubernetes, the weight of Kubernetes, often didn't line up with the amount of capacity that was available, in some of these single node deployments out on the edge. And, people were looking for something that was, potentially quite a bit smaller than what we were seeing, in deployments. We had, very often, once you ran Kubernetes for some time, you were kind of looking at a pretty large RAM footprint on the host. Similarly, it really Kubernetes wasn't built to be offline from from its management plane. It wasn't really expect if it wasn't available to connect to the internet, you just had to really do a lot of working around that. So we wanted to kind of take some of these considerations in mind, as well as really thinking about how we could simplify the operations of Kubernetes, and all that drove us to look at K3s. So with that, I'll turn it over to Darren and let him dive into kind of how he built out K3s and what some of its capabilities are. Darren, I'm going to make you the presenter. Can you
All right.
you want to share your screen?
Yep. Let's see. And okay.
You're
All
off.
right. You can see it?
Yep.
All right. All right. So introducing K3s. So I think one of the biggest questions we get from people is how do you say K3s and what does it mean? And we don't actually have a straight answer for that. I typically say K3s. I think K3s sounds good too. And then what exactly does the name mean? It doesn't actually expand to anything. It's just a play on k8s, which is the shortened version of Kubernetes. So we wanted something that was half as small as Kubernetes, and so K3s would expand to a five-letter word. Kubernetes is a 10-letter word. So people have had kind of fun with the name, trying to figure out what it is. We don't actually have a real answer for it. But anyway, so let's see, K3s. So I think one of the things that makes K3s quite different, because I think the idea of creating a smaller Kubernetes or a lighter weight Kubernetes or something that's simpler, a little simpler to run, people have tried this in different ways, but it's typically focused on development. So you have like Minikube, which I think came from like local cube, and then there's like micro-k3s, and there's a lot of different distributions that are kind of tailored towards development that try to make it a little smaller, easier. But what we really wanted to focus on with K3s is that we wanted this to be a real certified Kubernetes distro. So when we launched this, when we publicly announced the project, we were already certified. Got certified that day when we announced it. And then we really want to focus. This is really for production clusters. We've had a lot of people really interested in using K3s for like development, or possibly it's like a Minikube replacement or Docker for desktop, because it is smaller, lighter weight for like the laptop. But that wasn't even actually our intention when we began. So we really want to focus this on production. And so that's kind of the main difference between people will ask, like, what's the difference between this and like micro-k3s? And that's really what it comes down to. Is this is a certified distribution for production, and it ends up working really well for the edge. So K3s is packaged as just a single binary. It's about 40 megabytes. It's slightly smaller than that, but it's about 40 megabytes. And a single node cluster will take up about 250 megabytes of RAM. So that's about a fourth of the size of like a regular upstream Kubernetes distro installed using like kubeadm. For just a worker node, it's much less. I think it's closer to like 40 to 70 megabytes, just depending. So that's kind of just like the base memory footprint. So it's much smaller, so we can fit this on smaller like ARM devices, and so this will run quite comfortably on a Raspberry Pi that has a gig of memory. Still leaves about over half the memory for your applications. Okay, so basically what we've done is we've kind of integrated the various different components, like Kubernetes is packaged as like the the API server, the controller manager, the scheduler, the kubelet, kubeproxy, the container runtime. It's kind of everything's all kind of packaged as separate binaries, and it makes sense when you're running a large scale cluster, but for the smaller use cases that we're looking at, we don't need to do that. So a lot of the memory savings that we got is actually just combining processes and packaging it just a little different way. One of the big changes we made was we swapped out etcd for SQLite. It's in addition, so etcd will still work, We have every intention to continue to support etcd, and for the HA setup of k3s, it'll probably still continue to use it etcd. But for the use cases that we're looking at, where we're much smaller clusters, we want simplified operations and everything. Having a single master works for a lot of use cases, and so in those situations, we just put in SQLite instead of etcd, and it cuts down the memory footprint significantly, the binary size, and it's a lot easier for a lot of people to handle. I mean, because it's just a SQLite database. You can look at the database just using regular SQL queries. It's just a single file. Basically, they have to back up if you want to, manage it, like do some type of automated backup and restore. So we want to make sure that this worked, seamlessly on not just Intel ARMs, but ARM64 and ARMv7. And I'd say that, once we kind of decided that we wanted to launch this project, more than half of our time was really just getting this to work really well in ARM. It was a lot more work than we thought it would be. Found quite a few bugs in different components and whatnot, because it's not as ARM is not as well, like ARMv7, for example, is not as well tested in the kind of Kubernetes ecosystem. So we put a lot of effort into packaging up, making sure everything works, kind of seamlessly across these. Because again, as we were looking at Edge, these architectures matter. So finally, this is launched as an open source project. It's not quite yet a product. The response, I mean, we just announced this, I think, less than 2 weeks ago, or about 2 weeks ago. The response has been like phenomenal. So if you're looking for support, or you want to put this in production, please call us. We're getting tons and tons of inbound requests about this. But right now we just launched this. The intention was it's an open source project. We will kind of GA this and make sure that it's production grade, but this is still early. We just announced it. But the response from people trying it out is that it works pretty well. We're not getting significant issues like gotchas or whatever, but there are little bugs and stuff, and we're still sorting out some things and tightening the security and whatnot. Okay, so
before you jump forward, there was probably a flurry of questions
sure.
kind of poured in specifically about the HA single node kind of thing. So there was can you just talk a little bit? It's like someone said, you said single nodes. What if the master goes down? Do you have any implementation for multiple masters / HA? So do you want to just talk? I mean, I think if you're going to cover that later, it's fine. But if you want to just kind of touch that, that was sort of a number of responses.
Yeah. So right now, what we announced, what's available right now, an open source, does not have an HA solution. We are going to add a full HA solution, so that the multi-master, highly available. If one goes down, another one automatically takes over. We're putting a lot of effort into that, and we're going to make it just as simple, kind of to get up and running as what we've done with the single node master. So if you really, really need a high availability solution, then that will be coming. And it's going to be based off of, we'll most likely continue to use etcd, a more slimmed down version of etcd, because it'll be kind of bundled in, and then additionally use gossip and whatnot to do node failure detection. And so we're putting a lot of effort into it. But what we're seeing is that there's a lot of use cases where you don't need high availability for the Kubernetes API. So you have to realize that we're talking about the high availability of the Kubernetes control plane. That is already designed such that if the control plane goes down, your applications are still running. So if like your Kubernetes master dies, like your application is still running, networking works, like all the requests, everything will go fine. So for a lot of the situations that we're looking at, people don't necessarily need highly available. I mean, highly available means like 5 nines. With a single master setup, you can get a highly resilient setup, which means like basically if your master goes down, you could restore it very quickly somewhere else, because again, the state's just stored in like a single file. And so a lot of the stuff that we're doing right now, people are just looking at doing something like that. So you can get quite far without requiring a highly available one. Um, so that's kind of where we stand right now.
What's your estimated timing for the HA stuff?
Um, I mean, I think ideally would be in the next 3 months, but I'm not going to like guarantee that. So I'd probably say like 3 to 6 months.
Awesome. All right, why don't you keep going?
Okay. Okay. So basically, what do we do to make this kind of smaller, or kind of what's different? We removed a bunch of things to make it smaller, and then we added a bunch of things to make it a little easier. And that's fundamentally kind of like what is K3s. It's on the one hand, it's a lightweight distribution in Kubernetes. Right now, we do give a hypercube binary. Like if you just wanted something that was more vanilla, you can just download like a hypercube binary. I don't. We're still kind of fully testing it, make sure that works. But the so K3s is really two things. One is the lightweight distribution of Kubernetes. We removed a bunch of things, and then the second is we wrapped it in a really nice kind of like installer, not necessarily installer because there's no installation up like step. So it's just wrapped in a nice user experience. It's really easy to get up and running, and you'll see that when I demo it. So what are the things that we removed? So people always get really afraid of this, of like, oh no, you deleted all this stuff. Is this going to be like, this thing's not going to work quite right. It's going to have a bunch of gotchas and whatnot. And that's really not the intention of what we removed. The idea is anything that we're removing is things that are kind of naturally going to be removed from core Kubernetes anyways. Like Kubernetes started with, kind of everything being in one repo and everyone committing code. And then obviously that doesn't scale. So they started moving things out to external, like some way that you can install plugins that don't require it to be compiled in. And so we really focused on, removing all that functionality that has already been deprecated or is already, or was never really caught on, or is going to be moved out anyways. And there's already an option, outside of core Kubernetes for it. So first, that's like basically any legacy or non-default features. So there's a lot of old APIs that either never caught on or been replaced with a newer version. And so we removed a lot of the older ones that never really got traction. There's some old APIs that we did keep, like some of the old extension or apps APIs, like app beta, app beta v1 or v1 beta 1, whatever, something like that, because they got like huge traction, even though people shouldn't be using the beta ones anymore and should just use the stable ones, but they're still out there in the wild. So we went through and we just kind of found, okay, these APIs really, we're not seeing them used anywhere. They're old, they're going to be deleted from Kubernetes eventually anyway, so we got rid of those. That, like these APIs, just by removing the APIs actually reduces quite a bit because there's a lot of generated code in Kubernetes around APIs. So also any non-default feature. So there's a lot of features that you can do on the Kubernetes API server that aren't available in, like, let's say GKE or EKS or AKS, any of the cloud hosted Kubernetes that don't let you manage, like they manage the API server for you. So there's a lot of options you can't turn on. So like you just kind of have, so all of those features that you can't turn on in a cloud hosted one, we kind of figure, for the most part, you shouldn't be using those because it's not really portable. It's not going to work everywhere because you don't have that ability to flip it on. So most of those features we removed. That mostly means admission controllers that aren't on by default. So most of the admission controllers we turned off. So admission controllers in general can be implemented using the webhook or the validation, like the webhook approach, the validating and mutating webhooks. So, there's not much loss there. If you can't use the built-in one, everything can actually be done externally. Okay, any alpha feature we removed. So again, alpha features in Kubernetes are not enabled by default. So if alpha features, we deleted them. If you want to use an alpha feature, kind of at that point, just use an upstream. K3s is probably just not the best place if you want the bleeding edge stuff. So any in-tree cloud provider we removed, and in-tree storage drivers. So this is actually a huge amount of code that, like in general, I think overall we removed, I think it's around 3 million lines from Kubernetes. But that's not all code. So I'd probably say it's probably like half of that is code. There's also like tests and some other things. So it's like, but anyway, so we've removed over like a million lines of code. And so the most significant stuff was actually the cloud providers and the storage drivers. And again, it's not that we're removing the functionality, it's that these drivers, this stuff is all available as add-ons. Like you can just deploy, um, you deploy these drivers now. So instead of using the in-tree Amazon one, there's an external one. And so that's kind of the direction the community is going anyways. They want everything pulled out of the core and have it as like a plugin kind of to install the Kubernetes. And so we pulled all those things out. So again, we're not trying to remove any functionality. It's just it's just not there by default. You're gonna have to install it. For things like cloud providers, K3s is really not geared towards, if you really want deep integration within the cloud, then we really just say, hey, EKS or GKE or AKS, or DigitalOcean Kubernetes, one of those, the cloud hosted ones are going to give you a better experience, like a more integrated experience anyways. You might as well just go that route.
Darren, there's a good question, I think, that came from Rohan, and he said, well, how do you remove stuff, and which approach to easily update or maintain as new kube versions, case versions come out? Like, what's the process of removing, and then, how do you keep this up to date with new versions of Kubernetes?
Yeah, I mean, so by removing, we're actually just removing lines of code or deleting files and patching it. So the process right now, I mean, it's a fairly involved process. We're maintaining like a patch set that's probably like 100 patches or something like that. So K3s came from a different project I was working on, Rio, and I've been working on it for about a year or so. And so we've been maintaining these patches because we started this quite a while ago. So I've been doing this for about a year since Kubernetes 110. So we did 110, 111, 112, 113. And so we have a good handle on what it takes to kind of manage this. So it's not very hard for us to do this because this is kind of, what we do kind of in general. We've been managing in Kubernetes distributions for a while now, but it is a good amount of patches. But it's not, I just want to make it clear, it's like we're not forking, as when Kubernetes 113 came out, I mean, we had that patched. So this was before we actually announced K3s, but I've been doing this as a part of a different project. So when Kubernetes 113 came out, we had it working within a week. Patch releases, major minor. So for a patch release, like a 113.4 or .5, those really take no effort whatsoever. Those are really simple to upgrade to. But when we go from a 113 to a 114, it's more of an effort, and we have to kind of look at all the changes and whatnot. And so it's quite a bit of effort, but we would really hope that what we can do is we can eventually upstream all of this. We weren't quite sure how many people really would if this was a good idea or whatnot. As we've launched K3s and the response has been like pretty incredible, I would actually like to get most of this upstreamed, that we can do this all with actually just using we can do this all with Go build flags or tags, but we haven't really put in that effort. So I would say eventually I would really like to see this all get back upstreamed, or Kubernetes just deletes this stuff themselves. So over time, we hope this gets easier. All right, Shannon, should I keep on?
No, keep going.
Okay.
There's lots and lots of questions, but I'm trying to answer them.
Okay, so so last thing was that we removed Docker, and this is optional, but by default we just run with containerd. So this is containerd. Containerd is used by Docker already. But containerd, by running Kubernetes directly on containerd and not on Docker, you just kind of remove this big fat layer that's just not necessary. Just doesn't really provide a lot of benefit unless you have kind of older tools that don't integrate with the container runtime in like a Kubernetes native way. But most of the tools are moving over to that. So we haven't seen like a huge pushback here. But containerd is just, it's just a lot better, much smaller, more secure because it's less code. So just kind of a better option in general. And this is the direction that everyone's kind of going anyways, of just moving to a CRI runtime. And so containerd is one. We also, you can run cryo, you can run any CRI with K3s, but we specifically made sure that cryo works too. But by default, we go with containerd. So again, this removed a lot of memory and simplifies things. So that's kind of on the left side of what we removed. So what do we add? Basically, we've made it much easier to install. You'll see that in the demo, kind of how that installation works. We added SQLite, which I already kind of talked about a little bit. We do all the TLS management kind of automatically for you, so you don't have to manage that stuff. We generate all the certs and kind of distribute them, so you just don't have to kind of fool with that. We have kind of automatic manifest deployments. If you're familiar with static pods, like how you can just put a pod definition in a directory for the kubelet, it'll just deploy it. We have a very similar thing where you can just put like manifest in a directory and it'll deploy it. And I'll show that later. And we have some built-in Helm chart management. So this is like all around kind of this use case of making it really easy to package up applications with K3s for a couple use cases I'll talk about in the next slide. So beyond just the core distribution of Kubernetes, we also include the container runtime, which is containerd, core DNS, and Flannel, and traffic. That should be on there too. We have traffic that we're using for the ingress controller. So the idea is that we give with K3s, when you install it, you should have pretty much a fully functioning Kubernetes cluster. So like if you were to install something, let's say like with kubeadm, kubeadm gives you the base Kubernetes, and then you're gonna have to, well, before you even do this, you need to install a container runtime, and then you run kubeadm, and then you'll need to install the networking, and then you need to figure out an ingress controller and a service load balancer, like maybe some cloud provider integration, and then additionally some storage solution like a storage class. So with K3s, we really wanted, it's like when you install it, you pretty much just get a fully functioning Kubernetes cluster. You don't have to make all these choices, but all the choices that we make for the user, they're all optional. They can be disabled and replaced with something else. So if you don't want core DNS or Flannel or containerd or traffic, you can replace all those. Okay, so in this slide here, this is just kind of how we packaged it up. So we have a server and an agent. That's kind of how we just described it. We took all the components and just kind of presented it to the user as just a kind of like a server agent architecture. Just kind of make it easier to kind of conceptualize what this is. And so on the server, you have pretty much one process, and in that process is running the Kubernetes API server, the scheduler and controller manager, like those are your standard control plane components, plus the embedded SQLite. And then there's this component we've added on, which is a tunnel proxy. And what this tunnel proxy is, the reason why we did this is we've changed it such that the agent, like where the kubelet and the containers are running, is only required to make outbound connections to the server. In a typical Kubernetes setup, there's bi-directional communication between the server and the agent, which means the agent needs to talk to the server and the server needs to talk to the agent. This makes it a little harder to set up security groups and firewall rules and whatnot, especially when this starts, if you have nodes that kind of cross different security boundaries and whatnot. And so from a networking perspective, it's typically just much easier to only make outbound connections and not to allow inbound. It's easier to secure, it's easier to set up the firewall rules and whatnot. And so what this tunnel proxy does is it establishes tunnels from the agent to the server such that we can have the bidirectional communication that Kubernetes requires, but the connections are always established from the agent. And so everything goes through this tunnel proxy. And then we also, that's all encrypted SSL, and we kind of manage the certificates for it. And this helps us make some of the certificate management a little easier too. So that's on the server side. Then on the agent side, we've combined the kube proxy, the kubelet, and flannel all into one process. And then as a child of that process is the container runtime, which is containerd. So you're typically going to see two processes running on a worker node. So by default, when you run the server in K3s, it will run the agent also on the same machine. So you get like immediately a single node cluster. It's kind of the standard for, I mean, a lot of people run the kubelet on every host, including on the control plane. So we just default to that behavior. It's also requires less resources. Okay, so Shannon, was there any questions on that, or should I keep going?
Yeah, there's like about 150 questions. I mean, honestly, let's get to the demo. I think we'll answer more questions in the demo than you can answer this way. So
yeah, okay,
so
that's a good idea.
I'm holding questions a little more than usual. We have, God, so many people here. Keep firing them. I'm trying to answer them, but keep going.
Okay, that sounds good. Okay, so I just want to go over the use cases, and then we'll get into the demo. Because hopefully the demo will answer kind of a lot of questions. So use cases. So again, edge and embedded systems. Shannon went over this quite a bit. For IoT, a lot of people are like, will say like, how in the world can you get Kubernetes like on an IoT device, like a little sensor? And that's not usually the intention. Like the sensors, like those little tiny devices are just too small for much anything. But where Kubernetes does shine is like an IoT gateway, where you're deploying various applications. That is the software that sensors and stuff are talking to, or consolidating the data, doing more edge processing, so it doesn't have to go all the way back up to the cloud. And there's some pretty cool devices in this realm. So besides just edge and IoT, we're seeing a huge amount of use of K3s in CI. Just because it's so simple to get up and running, you can just very easily launch a Kubernetes cluster in a couple seconds. So people are using it in CI to like spin up a cluster real quick, run some tests, and tear it down. And a lot of different development use cases too. People are integrating this with like Vagrant and using it on the laptop for different reasons. So it's been quite popular kind of in a development realm. This last one here is the single app clusters, and this is becoming, it's kind of interesting we're seeing this more popular, and this is from a real pragmatic perspective of kind of Kubernetes started with this like idea of creating these massive clusters and putting all the applications on these massive clusters. And then for just a bunch of really pragmatic reasons, people have like these legacy apps that they can't put on these shared clusters, or they have very specific requirements of how they run, but they still want to be in Kubernetes. And so people are setting up these smaller clusters for just a single application. So K3s works really well because it's such a smaller footprint. It's easier to manage. There's not a lot of moving parts. It just kind of works by default. So they're able to very easily spin this up and dedicate just a single application for it. To take that even further, what we're seeing also is people are looking at taking K3s and bundling it with their application. So it's effectively like a Kubernetes appliance. I mean, their application is deployed like an appliance, but it actually runs on Kubernetes. And I'll show a little bit more in a demo of kind of how you can do that. But it's really simple. Of like, if you just write your application that's like an operator or some controllers that maybe use Kubernetes architecture, or not even using the Kubernetes architecture, you just want to deploy a distributed microservices app, you can very easily package that up with K3s and deploy that. Okay, so let's get into the demo. So this is kind of some instructions from a website of how to get this running. So I'm not going to go through this. I'm just going to show it to you. Okay, so everything I'm going to be demoing here today is running on ARM64 servers from Amazon. Packet is also a great place to get Amazon servers. I mean, sorry, ARM servers. We use both of them extensively. I wanted to demo. Well, I wanted to show a Raspberry Pi, but as Shannon mentioned, I'm at Disneyland and hotel, and I couldn't get it on the Wi-Fi and set up or whatever. But I did want to point out, like, there's a lot of good blogs that are already out there of getting K3s running on a Raspberry Pi. So it's very feasible. It it works. It's really easy. So Alex Ellis he's leads the OpenFaz. He actually just did one a couple days ago. This is an excellent blog, how-to of getting K3s running on a Raspberry Pi. I also wanted to show one of our employees has been working on this setup. This hopefully we'll see much more of this. This is so the Rancher Cow running a little Raspberry Pi. We've big plans for those. But so there's a lot of fun things that people are doing with K3s.
That's really how we're monetizing this whole thing. We're going to be selling to Walmart's.
Exactly.
CubeCon.
Yeah, so people have been doing a lot of fun things on Raspberry Pis, but but what I'm going to be demoing here is all on ARM64. So I have a couple of machines already spun up in Amazon, and hopefully this all works. We did a webinar for CNCF a couple weeks ago, and it failed. So this time, hopefully, it'll work better. So what I'm going to show you first is the manual installation, and then we have this curl script, this install script that you can run that basically does everything in one shot, and it's much easier. But I'll show you the manual just so you understand like what's going on. So you can go to our website is k3s.io. This is a very basic website, but from here you can go to GitHub, and where you'll find the downloads for K3s is going to be in the releases. So 020 is the latest. We just did this 5 days ago. We plan on probably just putting out releases about every 2 weeks, just like on a regular cadence, as we're fixing issues and whatnot. But so you can see here are so this is the Intel version of K3s. You can see it's about 36. So it's a little less than 40. For some reason, ARM is even smaller than Intel. But so this is the Intel version, ARM64, and ARM HF. This is for ARM v7 boards. So we're going to go with the ARM64. So let me just copy that link and then go here. And so we're just going to download resolving GitHub. Oh man, I was afraid that was going to die. The very first thing. Okay. So let's just make this executable. Rename it as K3s. So to launch it, look here, I'll just so to launch it, you're just basically going to run K3s server. Let me see if I can just do like help. Hopefully this way. So you can see the binary has server, agent. This is kubectl. CRI-CTL is kind of this is to talk directly to the container runtime, and so this is kind of like your replacement of Docker. Like when you're trying to troubleshoot Kubernetes, like and you go onto a node and you start running Docker commands, instead of running Docker commands, you can run CRI-CTL, and this will actually work with any CRI implementation. So containerd, cryo. I don't think it works with the Docker shim. But this is kind of like your replacement for like doing the node level debugging. I'll show that once we set up a node. Okay, so as I said before, this command has server and agent. So to get it running on the server, we're just gonna run K3s server. So you can see it's starting up. Creating some things. Once you see this thing here, right up here where it says listening on 6443, the server is up and running. So you can see it, I don't know, took a couple seconds there. These ARM machines from Amazon are pretty darn fast. They're pretty equivalent to an Intel machine, quite impressive. Um, on a Raspberry Pi, if you're running this on a Raspberry Pi, the very first startup is going to take over a minute because it has to generate all these certificates, and the generating the private key takes a long time on a Raspberry Pi. Like, I don't think there's hardware acceleration for it. Uh, and But then after that, it takes like maybe 5 seconds. So even on like a Raspberry Pi, it's still pretty quick after the first start. Okay, so once the server is up and running, so I just launched this. Let me background the process. Okay, so once this is up and running, so as I mentioned before, when we run the server, we automatically run an agent too, so it becomes a single node cluster. If you don't want that behavior, you can disable it. There's a bunch of arguments here, but basically you can just say disable agent. So then you'll just get just the server by itself. But so once I have this running, so then I can just say kubectl. Let's see if it came up fine. Okay, so k3s kubectl get node. So we can see that's already up and running. I have one role or one node. All namespaces true. Shannon, I can hear you typing.
Oh, sorry.
Yeah, frantically answering questions. Okay, so so this is what's already running on the cluster. So you can see this just came up. I mean, super quick. One thing I wanted to point out before I describe this stuff is, so like I'm typing k3s kubectl, which can be super annoying because you're typically used to just typing kubectl. So you can just symlink kubectl or k3s to kubectl. So then I can just say kubectl get node. So I don't have to type the k3s anymore. So if you're running scripts and whatnot. So just so that it's not the same thing works with the CRI-CTL also. Okay, so let's go back and look at kind of what we've got in this system now, what we've got running here. So when we bring up K3s, we automatically deploy core DNS. So we've got core DNS running here. And then we set up traffic. So we're using traffic as the ingress controller. Traffic was really the only ingress controller that I think we could find that worked well on ARM and Intel. I know a lot of people use Nginx. You can still run Nginx if you want. We would love to see Nginx support, but just recently they dropped support for ARM v7. So if that could get added back, then maybe we can use that. But I think traffic is actually a lower memory footprint than the Nginx one, because if you combine Nginx plus the controller or the Go process, it's slightly larger. But anyway, so this ended up being a good option for us. It's quite simple for our use case. So we automatically give you an ingress controller, so ingress will work out of the box. And then one thing that we did is, one of the common problems with Kubernetes when you're deploying a Kubernetes cluster is, if you're not running with a cloud provider, is that a service load balancer doesn't work. There are a couple service load balancers you can put in there, like Metal LB, but they're all typically pretty difficult to get running for most beginning users. So what we do is we have a very simple integrated service load balancer that basically just uses host ports. So here, when we deployed traffic, it created the traffic service type load balancer, and you can see it bound it. Like when we created the load balancer, it wants to use port 80. So if there's a port 80 available on a host, then it just sets up the load balancer on the host. So you can use service load balancing out of the box. It just basically uses host ports. And the way that we do that is we just run this very simple pod that pretty much just sets up an IP tables rule. This doesn't really take up any memory or anything. It's like 100K at the most. And this just uses IP tables and sets up a host port. So the service load balancer works. So the only thing, so there's two gaps we have right now that we will address, like before we GA this, is we want K3s to just be fully functional out of the box, but we are missing a network policy manager. We'll look at solving that. The second is that we are what was the second one? Oh, we don't have a storage solution yet, but I think we're going to deploy. There's a couple of these, but we also, Rancher, we ended up just writing one of these ourselves, but that basically local storage. So until you figure out what storage solution you want, we have this local path provisioner. So right now, if you use K3s and you want to use storage classes like PVCs, I would recommend you just install our local path provisioner, and then that will work. But honestly, like it's just using local storage, so that's not a great HA solution. So if you want something more resilient or whatever, then obviously there's a lot of different other storage solutions that you can deploy on Kubernetes, so you can just install those. But we'll probably include this by default at some point here. Okay, so let's see. That was kind of the rundown of what we have in a single node. So now I wanted to show you, okay, so that's just a single node cluster, basically just run the binary, it's up and running, it's pretty simple. Yeah, one thing that I think is not very obvious, when you start it up, it does print this, but I think a lot of people miss it, is that if you want to then use this, like talk to this Kubernetes from a different host, the kubeconfig is written here. So you can see it here. The only thing is by default, I think we put localhost in there, which is not like the best. So if you copy this over to another machine, just change the IP to your host name or whatever. Yeah, and then I think one other little gotcha that I think the number one issue we see when people are installing K3s is you need to make sure that the host name actually resolves to an IP. So whatever your host name is, this really needs to resolve to an IP. The easiest way to do that is to add it to your host file. Just put 127.0.0.1 and then whatever your host name is. So right now, that's the number one thing that I think people have problems when they start up. It fails. We're actually going to remove that requirement, but we have to get a little deeper digging into the kind of the kubelet to remove this requirement. But we're going to get rid of it, so so people aren't hitting that so much. Okay, so we have a single node. Let's set up a second node. Like let's join a node to the cluster. So when it starts up, it prints this command here. You can see it says to join a node to a cluster, just run K3s agent, that, and then the node token. So let me copy that. I'm going to go over to a second server here. I think I already downloaded. Yeah, I already downloaded K3s here. We're going to run this as root. Oops. Go back here, and then you need the node token. So the node token you're going to find in this file. It's going to be this big long token here, and this is how we set up like the secure connection. It both authenticates and then it helps us with setting up certificates so we can authenticate or trust the server. Okay, so then we run that. Okay, so that starts up, and then so that's starting up. Let me go back to here, and I should at this point, let's see, get node. Yeah, so I should see that's this the second one. So that node is up and running. Yeah, so now I have a 2-node cluster, so I can go and repeat the same thing, over and over. So it's pretty easy to deploy this and automate it. Right now, like that's the default behavior of, like you launch the server, it creates a token, and then you copy the token over to the agent or use it to join an agent. There's a different approach when you launch the server that you can use a cluster secret. So you can use a shared secret. And what this does is instead of waiting for the server to generate a token and then having to use that token on the agents, you can just have an agreed value ahead of time between the server and the agent. So you can just put in any long random string. And this makes it really easy to bootstrap a cluster. So if you're like automatically deploying, let's say like deploying something in Amazon or something, you just set up an auto scaling group and deploy the server. So it's super easy to automate this way. Otherwise, you need to like launch the server, get the token, pass it. So it just requires a little bit more scripting and whatnot. So this makes it a lot easier. So let's see. So on the server, both on the server and the agent, as I mentioned before, there's various things you can disable. So if you don't want some of our, like you can turn off Flannel, you can enable Docker, you can use any various CRI implementation. For this no deploy, you can disable core DNS or our built-in service load balancer or traffic. So any of the choices that we already made for the user, you can turn those off and plug in something else if you want. Okay, so now, so let's see. I just want to demo. So now that we have, basically we can set up. I showed you kind of the manual way of setting up a server. Let me show you kind of like the simple automated way, because so one of the downsides of what I just did manually is this process, it's just running. It's not. If the server was to die, nothing's going to restart it because I just launched it on the command line here. So what I want to do here instead is let me kill the server and kill the agent that I launched. And I can show you how you can use this curl script, which makes it significantly easier to set up machines. Not that was really that hard, but what this will do also, so if you do get k3s.io and then just pipe that to shell, so basically this will download whatever the latest release is, validates it, it creates an uninstall script, which is kind of nice, and then it sets up systemd for you and then launches everything in systemd. So now at this point I can just look at journal and say, okay, it's running here. I can say like systemctl status k3s. So you can say, okay, k3s is running in systemd now, and it automatically sets up the kubectl symlink and the CRI-CTL symlink. So those are really just with that one command there, you can it sets it up in a really nice way with systemd. So you really don't have to, like, this is a good good managed setup. So the similar thing you can do on an agent. The difference on the agent is if you want to do that, you're going to say, okay, curl get k3s.io, and then here you just want to put k3s URL. And if we go back to, let's see, you're going to see it in the k3s. Copy that over. Okay. And then we want k3s token, or as I mentioned before, you can put the cluster secret. Yeah, so then this sets up the k3s agent. Okay, so then you just have to run that, and that will set it up, the agent on there. Okay, so Shannon, next, the other things I was going to demo is pre-bundling applications and then registering this in Rancher. I don't know if you want me to go ahead with those things or if we should stop and answer some questions.
I think that we're doing okay on the questions, just kind of pounding through them. Why don't you keep going, and because we're already running kind of long, so let's keep going.
Okay, all right. So so the last two things I wanted. So this comes up quite a bit okay, well, how do I import k3s into Rancher? So Rancher, k3s is supported in Rancher 2.2, which is not released yet. So you have to install like 2.2 RC3, like it's coming out in a couple weeks. But you have to, like, if you install Rancher 2.1, it doesn't fully quite work. It mostly works, but there's some little gotchas. And that's actually the reason why is because in Rancher 2.1, there's some things that are tied to Docker. In 2.2, we're moving everything over to just requiring any CRI runtime. So if you want to import things into Rancher, I mean, there's really nothing kind of special or different here. You just go to a Rancher installation, just say add a cluster, and we're just going to do an import, give it a name, and like normal, we just copy the command and run it. So I don't have I don't have a publicly verified SSL. It is a secure SSL, but it's just not a publicly verified one. So I'm going to copy that and run that on the server. Okay. So then that starts registering with Rancher. This will take a couple seconds for it to come up. Let's see. Let's see. It's probably deploying. It's probably pulling in. Okay, yeah. So it's up and running. So yeah. So once I have this imported into Rancher, then I can start managing this in Rancher. Start using authentication, authorization stuff that we provide here. Like this thing is set up here with GitHub, so I can then go and let's see, like go to the cluster and oops, go to the cluster here, get the kubeconfig, and this is all done authentication through GitHub and whatnot. Start managing it, like deploy, monitoring, and whatnot. I'm not going to go through all this. This is just functionality of Rancher, but basically, if you're running Rancher 2.2, you can just import it and start using it. Okay, so the last thing I wanted to talk about here was this use case of, I can spin up Kubernetes really easily. Well, what if I also want to include an application? So there's three things that we provide to make this pretty easy. Is in the server directory, we have this manifest folder. Server manifest. So in here, I can just put any Kubernetes manifest, it'll automatically deploy. So you can imagine you have the k3s binary. You just put some YAML files into this directory, and then start k3s. You have Kubernetes running, it automatically deploys the applications. They come up. It's just a really easy way to package applications. So besides just any random Kubernetes YAML, we also have built-in support for Helm. So you can create this Kubernetes resource that's called a Helm chart that you can just point it to any chart. You can set some values, and so it just makes it really easy to deploy Helm. And so we do this in a lightweight and secure fashion. We run it like the tillerless model, where we basically, when we go to install, we run a tiller on the client side with the proper credentials and whatnot. And so we're using Helm, but it doesn't kind of have some of the security problems, kind of little security gotchas that might exist with Helm. So we would do it in a secure way. So you can very easily deploy applications. Then beyond that, besides the applications and the Helm stuff, is we can then do on the agent, if you create a folder here for images, you can then just take any you can then just take any Docker or OCI image export and just put it in here, and so you can pre-package the images so they don't have to go out to the internet. And so that's just done by if you have Docker, let's see, can't remember which one I had it on. You can just run Docker export. Sorry. Let me see if CRI/CTL has export. No, I don't think so. So I know the CTL does. So if you just run Docker export and you just give the image names, It just looks like this, like, foo bar latest, something like that. And then you pipe that to my images.tar. Then you can just put those tar files into this directory. When the agent starts up, it'll just automatically deploy it. So this makes it just easy to pre-bundle. You have your manifest, you have your images, you have the K3s binary. That becomes like kind of this Kubernetes appliance, and it's just really easy to package applications that way. Sorry. When we get the HA setup working, that kind of auto forms clusters using gossip and whatnot, then you can end up doing these appliances that are fully distributed and highly available. So there's a lot of use cases, a lot of interesting applications that we can use this for. Okay, so I think Shannon, I think that pretty much wraps up the demo.
Awesome. Awesome. There are so many questions, and so many of them are, reasonably technical that I'm probably gonna butcher them. So why don't we do this? Why don't we kind of jump through a few, and as we're going, I know you wanted to kind of go through a few more slides to wrap this up. So the questions really, one of the questions I think, there were a lot of questions about sort of manifests and charts and things that get, if you wanted to have sort of embed something to get started. And I think you've demoed that already. I know you were just showing kind of attaching a Helm chart. So did you cover that pretty much in depth?
Yeah. I mean, I hope most of it's pretty self-explanatory of, kind of how you can just package up by just the very simple, you can take automatically deploy any Kubernetes manifest, any Helm chart, and you can pre-package the images. That pretty much gives you like a full bundle of an appliance running on Kubernetes.
Got it. Okay, so there's another question. One of the people was asking, if you're using this with sort of more, so Bahara had said, does it make sense to use something like K3s on edge where you have pets and not cattle? So replication controllers might not make sense. And when edge setups have standalone devices far apart with poor network connectivity, where it doesn't maybe make sense to run the full control plane on each device. So like, I guess the question is really asking sort of where do you what do you think the right setups are? I have a lot of questions about different, can I run this where the master's in the cloud and the nodes are on the edge? I mean, from your perspective, where should someone be using Kubernetes in just native K8s, upstream, RKE, whatever? Where should they be using K3s? What do you think the right use cases are for these different projects?
Yeah, I mean, I think K3s is really, I mean, it shines for smaller clusters where you kind of need lower touch operations. Simpler, kind of like a more simpler, well-known situation. If you're running, large clusters in the cloud, you have DevOps and all this stuff, then, you probably just want to go with the upstream distribution and, use some cloud provided one. But we're really looking like with K3s of like, these kind of simpler setups where it's like, I know, on the edge, I have 10 devices, they're running these applications. I can just package it and, just deploy, like I can just kind of pre-configure it, turn it on, and I don't really have to think about it. And that's really where more like K3s shines. We don't really recommend running the master in the cloud and nodes on the edge. We really, the way Kubernetes is designed, you really want the control plane and the agents to be closer together. So we put the whole cluster on the edge. We're working on solutions now where, like, if you have the whole cluster on the edge and you have a lot of these clusters, how do you then manage all of those clusters? And so we're working on solutions in that area. Kind of management of all these clusters and thousands of clusters and thousands of applications, and how do you do that? But yeah, so that's kind of where we see it shine. We think, I think it's really interesting because when we first started down this route of, because I think our first inclination with Kubernetes was like, oh, this thing's like too fat and complicated to put on the edge. And we started getting all these inbound requests, and at first we're like, I don't know if you really want to do this. And then as we started looking at it more and more, we realized that there's a lot of benefits and that we could actually get it light enough weight and simple enough from an operations perspective that it will work for the edge. And so people are just seeing, like, even if you don't need all the huge power of like replication controllers and all this stuff, you want to do like, I'm just going to, deploy a pod and I'm going to pin it to this node, or I'm just going to daemon set. It's the same thing running on every server. Like very simple setups is, there's still a lot of benefit to running Kubernetes, even if you're not leveraging all the functionality of it. And it just comes down to like the consistency of like that same thing will run on your laptop or any other environment. I think one of the hardest things you always have with doing like edge or embedded or whatever is like trying to figure out efficient ways to develop where you're not like having to like constantly be cross-compiling or moving things, from your laptop, flashing onto a device and running it and testing it. And so being able to just use Kubernetes and developing, it's like you can do a lot of stuff just like on your laptop, and it's pretty much the same runtime environment that you're going to have on the edge. So there's a lot of, people are just seeing a lot of practicalities of it's just easier to develop and it's easier to manage, even if they don't need all of the huge functionality of, that Kubernetes provides.
Awesome. Another question, and there was lots of questions sort of about this, was sort of what happens with access to the hardware level resources? Like, can we use, will this work with GPUs and NICs and USBs? There were multiple questions on the same topic.
Yeah. I mean, so the thing is you can get full access to everything under the hood. It just depends on how you want to do it and like how cloud native or how kind of legacy you want to do it. There's kind of the nice thing about containers is you can kind of do it in an idealistic way and it's portable and it runs anywhere, or you can break all the abstractions and get full access to everything underneath. And so Kubernetes provides some decent frameworks for like GPU. There's this device manager, which will manage like NVIDIA devices for you and do scheduling and give them to your applications. And so there's a nice framework for that. But maybe what you're trying to use doesn't have a nice framework. You can just do something more straightforward of just like, well, launch a privileged pod, bind mount in whatever directories you need or devices, and then just use them. So a container can use any hardware device, whatever it is. And so I think one of the primary, we're getting a lot of requests is for people who are running the stuff on the edge, as they are using these kind of proprietary hardware stuff of GPUs or other to run AI workloads and stuff like specialized AI chips and stuff like that. And so it definitely works. It's really not all that difficult.
Darren, I think one of the big trends of questions that got asked, and there were just tons of them, were about like, would this run on, someone asked about, would it run on x86 32-bit? Would it run on Mac? Would it run, in kind of different types of, would it run on Android and Chrome OS? So we had a lot of questions. So could you run K3s inside of a Kubernetes, like almost virtualize K3s inside of Kubernetes? And so lots of questions that kind of get to, where all can this run? There were some questions that, like, what's the right ARM architecture?
Yeah.
So maybe talk a little bit about that.
Yeah, and I don't think I really fully talked about kind of what are the OS requirements and the hardware requirements.
Yeah.
So a couple things is, so basically the architectures, so this only runs on Linux. So we have gotten like, hey, can I run this on my Mac? It's like, well, if you're running it on a Mac or Windows, that means you have to run a VM. So you have to run a virtual machine on your laptop and then run it in Linux. So this is definitely, right now it's tied to Linux. We will definitely be looking at Windows support, but right now, just assume it has to run on Linux operating system. So the only architectures that we support are 64-bit. So 32-bit is just not very feasible. Technically, we can compile all of our stuff for Intel 32-bit, but you're just not going to really find many Docker images or if you do, it's like everything you're going to have to do is going to be very custom. You're not going to be able to just use like a Helm chart because you have to replace all the images. So it's like if it really, 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 really matters to you, you could probably compile it yourself to 32-bit and then go through all the hassle of finding images that actually work. But there's just not a good ecosystem there. So Intel 64-bit, ARM 64-bit, and then ARM v7. So we don't support ARM v6. So an ARM v6 would be like the original Raspberry Pi or older devices like that. So it has to be like a fairly recent ARM board. I mean, I guess something in the last maybe like 3 or 4 years. So the ARM, so again, the reason for like the limiting the architectures to just those is because those are the ones where an ecosystem exists. So theoretically, you could probably compile this to other things like I would imagine PowerPC would be a decent one to compile to, but it's just whether or not you can find the images and whatnot that are actually required, like the Docker pod or like the Google Pause image. Like that's actually the reason why ARM v6 won't work, is because you launch Kubernetes and then the pause image will just segfault on you. It just doesn't run on ARM v6 for some reason. So yeah, so those are okay, Linux, and then those are the architectures. Now, what do we require from an OS perspective is we need a fairly modern kernel, basically Linux 3.10 and greater should work. Most of our testing is typically on a Linux 4 kernel, but I think we can go back to like 3.10. We basically just need a kernel. Let me see, the OS requirements are the kernel and that we have a proper setup of the sys file system and proc with like the C group setup. But then beyond that, we need nothing from user space. K3s is actually a full, includes kind of like a BusyBox distribution of Linux. So we package in all of the OS level utilities that we need. So you could pretty much get K3s running on an OS that has no user space as long as it had the mounts set up for us. So there's really no dependencies there, so it should pretty reliably work on pretty much any Linux distribution that has a proper kernel. So the biggest thing is just that the kernel has all the support. So that's where we kind of run into the biggest problem of like people are like, well, will this run on a, I don't know, a Pine 64 or an Orange Pi or all these different various ARM devices. And so the biggest problem we run into all the ARM devices is, does the kernel that they give you have all the features turned on? I think the best litmus test is, does Docker already run on it? Since there's already a, kind of vibrant Docker community running on ARM already, is, if that device is already running Docker, then there's a good chance that K3s will work. If it won't run Docker, then K3s won't work. So there's various kernel options that need to be turned on. We don't have those all documented. They're just like the standard ones, but we could probably figure out what all those options are or start collecting them. But again, so that's the biggest thing of like, will it run on this? And it's like, well, it just mostly depends on your kernel. So if it's a regular, standard distribution, it's probably going to work just fine. It's only when you get into these ARM devices is the ARM vendors produce all these funky kernels and with weird options turned on and off. Okay, so that answers that. The other thing is, will this run on Kubernetes? Can I virtualize it? Can I put it in Docker? And the answer is yes. And there's a lot of fun things you can do there. If you look in our K3s repo, there's a Docker compose file. And this is the best reference kind of on how do I run K3s inside of a container. There's also, there's a good one for, I wonder if I can find it real quick. There's also a good one of running inside of LXD. I thought it was on this one we referenced it. Oh, there's a blog. If you look for K3s LXD, there's a good blog someone wrote up on how to run inside of LXD. But basically, yeah, you can run K3s inside of Docker in a container, or you can run on top of Kubernetes itself. And so what you can do is, like in this Docker Compose setup, I have the server and a node, and then if I scale up the nodes, I just get more nodes in that Kubernetes. So what you can do is you can set up like a, you can set up like a deployment for the number of virtual nodes, and then scale those up. So you can do a lot of fun things with it. Uh, so yeah, so that'll all work. You can nest things to your heart's delight.
One other question was about what versions, just kind of in the same vein, what version of Kubernetes is available with K3s right now, and how quickly does it move forward?
Yeah, so right now we just plan on tracking like the latest version. We're not going to like support older ones. So 1.13.4 is what we're based on right now, which I believe is the latest, unless they happen to release something in the last couple of days. But so it should be on the latest release, and you should see that we will be adopting. I hope within a week or so of when something is released. Like, we'll try to stay on top of it. But we have every intention of keeping up with every release. So I think when 1.3.4 came out, we had it working the next day. We had an RC for K3s the next day after 1.3.4 was out. So those stuff we try to track, because again, like besides K3s, we also have RKE, we have Kubernetes we package for our Rancher 1.6. We have to package up Kubernetes a lot of different ways, so we're tracking these things. So we're going to do our best to stay up to date. So I think if you're like looking for a guarantee, I'll say definitely within a month, but it should be much faster than that.
Hey Darren, why don't we wrap up and talk a little bit about the last couple slides, and then we can come back to just 100 questions.
Yeah. Did you want to do the slides, or do you want me to do this?
Go ahead. You've got your thing sharing already. If you don't mind.
Yeah. So the last thing, so when we start talking about K3s running on the edge, and is now it kind of changes this paradigm of initially, Kubernetes, the whole idea was like these big clusters, and you put all this applications, and we're kind of doing the inverse of that, of like, now I'm going to have tons and tons of clusters. How do I manage those? So this now becomes this problem of basically, well, how do I do this like kind of fleet management? I have thousands of clusters. I can't, be looking at each individual one. How do I manage these things? And so this is where we're headed right now, of building out solutions in this area, where the basic premise is I have thousands of clusters and thousands of applications. How do I manage them? So this becomes where I need to start grouping application or clusters into like batches, and how do I roll out applications? How do I know what app is installed across all these clusters? And then basically, how do I get access to them? Because they can be in all these various places. They can have bad connections. Just basically managing all of these thousands of clusters. And so this is there's a lot of similarities, and there's kind of some differences to like kind of what we currently do with Rancher. So some things are similar, of like kind of monitoring and logging, like the same basic functionality, but it just gets kind of tweaked, because like, for example, monitoring, like what we do in Rancher for monitoring is we'll run Prometheus and we give you live metrics. Well, I can't be giving you live metrics if your edge cluster is running over like an ISDN line, which is like, seems silly, but like that still exists today. People have like, all these remote locations that have poor internet connections and are always on. So how do I monitor these things, given that I don't have a live connection to them all the time? How do I manage the applications? Because it's not just like, okay, I have this application that's deployed in, 100 clusters. What version is it? It's also what's the, it's like, I have 100 these clusters that are all very similar, but then this one parameter is tweaked because this one is in this region, and so I changed the region parameter there. And so kind of managing the configuration of the applications, and as they're deployed across a huge fleet of clusters. And then just basically managing policy and security for all of these things. And then beyond that is we're looking at if I have K3s running, so like we have this project Rancher OS, which is for running Docker containers. And so we're now starting down this path of like, well, what if I created an operating system that's just tailored to K3s? Because that's really all I need. I just, like, once I have the OS booted and I have a Kubernetes instance running there, I can actually do everything like with that Kubernetes instance by just deploying and running pods. So now we're looking at basically stripping down Rancher OS, which we feel is kind of even too fat for embedded in some of these use cases, making a smaller version of Rancher OS that's tailored to K3s. And then when you plug this into the kind of the whole fleet management and everything, is you get like the full management of the operating system, the Kubernetes runtime, your applications, and so it just kind of becomes a turnkey edge solution. Yeah, so I think that's it, Shannon.
All right, well, let's dive into some more of the questions. With that, guys, feel free to drop off if you don't want to hear more of the questions. We're not going to be going through any more specific content, but you can, if you haven't already, take a look at, if you jump to the next slide, Darren, I think it's got our GitHub links and stuff, but you can easily see, where you can kind of pull down K3s from on GitHub, find the docs, etc. So definitely take a look at that, and if you have questions, file issues, there's a K3s channel on our Slack, so you can find us there. So lots of ways to ask more questions as we go, and Darren and I are always around online, so it's quite easy for us to share all this stuff. All right, with that, let's start looking at some of these questions that came up. So Alan asked, if I've run a K3s agent on Pi0 W, how many cores is the minimum recommendation for the agent/server?
Oh, so there's not a for the cores, it doesn't really matter. You can just have one. But I know a Pi0 is not going to work, unfortunately, because Raspberry Pi Zero is ARM v6, unless there's like a newer one. But the Pi0 that I was working with, it won't work because it's ARM v6. So like K3s will actually launch and come up, but as soon as you launch a pod, the Google pause image will just segfault on you. That one I really wish worked, but again, like we kind of drew the line of like, we can get v7 working. V6, there's just really poor support from the community on v6. There's just not a lot of images available. You're not going to get very far.
Well, that was actually another question that there were a number of good questions around, and it was, if I'm using K3s on ARM, I assume I need to use ARM specific Docker images. I assume that's the case, but maybe you can just comment on that and where you can find these things, etc.
Yeah. So it's like if you're using ARM, you need the ARM version, and so there's, the ARM ecosystem has been growing and growing within the Docker community. So the Docker and Kubernetes communities. So there's actually a good amount already available. So all of the standard Docker, like kind of the Docker library stuff, is pretty much already all works on ARM already. So there you can find a lot of multi-arc images already. What a multi-arc image is like, it's an image, so let's say like Ubuntu, if I just say like Docker pull Ubuntu, that image is available in each architecture and it'll just pull the right one. So if you pull an image and you go to run it and it fails and it gives you something that says exec format error, something like that, then that means, it wasn't compiled for ARM. So again, K3s itself, like Kubernetes and K3s, we can compile for a lot of architectures. And so the only thing that really holds us back is just whether or not there's a reasonable amount of images available, like how far we can get.
Makes sense. There's another question Waleed asked. He said, do I still need a root daemon even if Docker is optional? I'm looking for a secure rootless install as much as possible.
Okay, so let me break that into two things so I don't know exactly what you're asking. So the first is, do I need a daemon? Yes, you need a daemon. Like all of Kubernetes requires daemons, so we can't get rid of daemon. So it can't be daemonless. But do I need root? So K3s, I just put in a PR for this. I'll show you here. Let's see if I go into pull requests. Okay, right here. I just put in a PR for this. I'm working on this. This will be in the 0.30 release, which is this is full rootless support. So this is running Kubernetes or K3s without root. So you can just run this as a regular user. So basically just add the -- rootless. And so this will work. I have it working. It doesn't require root, but I will say the user experience is kind of tricky because of networking. And so there's some little things. So you're gonna have to like kind of understand some of the little gotchas around the networking, but it will basically still work. Let's see. Okay. Yeah. Okay. So I think we will be supporting rootless. I think that one is like just rootless is really just kind of materialized in the Kubernetes community just in the last couple of months by this guy here. I don't want to butcher his name. So we're going to continue to kind of invest in that because I think there's a lot of interesting use cases that we can do, higher security stuff that don't require root.
There was a couple of people who asked a question about Balena, and is this something that would work with Balena or is it a competitor to Balena? I'm not super familiar with it. I thought maybe you might be Balena.io.
Yeah. So this works with Balena. So if you run K3s, just do the -- docker when you run just pass the docker option. And then you just, for Balena, you just need to, I don't know if Balena does it by default, but you just have to basically put the Balena socket as the Docker socket, like in var run docker.socket, just symlink that to the Balena socket, and then it should work fine because Balena supports the Docker API. So I'm pretty sure like all that should work just fine. I actually I just got a Balena fin, which is a really cool device from those guys. So I've been fooling around with it quite a bit. So hopefully it should work fine. But the container D, so the container D is going to be lighter weight than Balena. But Balena has some better things around image pulling, which are interesting. They have some optimizations there. I would love to see, honestly, I'd love to work with those guys and maybe consolidate some effort here if they're, as they move forward and integrate that stuff into container D, if we can kind of leverage some of it.
Okay. There's some questions about if Submariner would work with K3s. Any reason it wouldn't?
No, you just have to realize that so like when you set up K3s, they can't have overlapping seeders right now. So just make sure when you set up Submariner, they can't have overlapping seeders. So just make sure that when you launch the K3s instances, you change the cluster seeder and the service seeder. They're just arguments on the server. Just put them to something that's not the default.
Okay. There was a couple questions about the memory consumption and CPU utilization of K3s when it's running. You want to just chat about that? We kind of talked about it, I think, at the very beginning, but maybe just mention that.
Yeah. So so the default installation, it's like it starts off for a single node cluster is about 250 megabytes. For a worker node, it can be more like 40 to 70. The CPU, we're still working on trying to get the CPU lower. So let's see. You can see here, like this is if you look at my screen here, this is a dual core machine. You can see the CPU sits here at like, let's say floating around 10% of one core. So we're trying to figure out if we can, what's causing the CPU. So this is just a kind of a Kubernetes thing, kind of in general, kind of Kubernetes is constantly like looking at desired state and reconciling it and kind of runs this this logical loop all the time. And so we're trying to see what we can do to optimize that and get it down to a lower. So it does use more CPU than we would like to, but at least it's not like killing the machine. But it's not at like 0%.
So Lee asked, and a couple other people asked about this as well. Is there any way? I mean, what's the offline support like? Like, how do I run this if I'm in a data, if I'm kind of air gap networked, or if I need in development environments that are not internet connected? Anything you can talk about there?
We're still working on like a full air gap because unfortunately when we start up, so there's two things that we need to do. One is prepackage the images, so you can just put a tarball on all the hosts, so it doesn't have to pull the images from the internet. The second is since we use Helm to install traffic, right now that goes out to the internet, and so we need to basically change the Helm installation so it doesn't have to go out to the internet by default. So right now, it is possible to run it offline if you prepackage all the images and you disable traffic. But we'll try to make that even better. So like just the thing just by default, if you just download the images, the image tarball with the binary, then it won't require internet at all. So still working on that.
Okay. There was a question from Alexei. He said, if you don't have Docker, how did you get Helm to work? Do you have like a non-standard Helm tiller? Because he thought tiller relied on Docker engine as far as he was aware. Anything you had to do to overcome that?
No, nothing specific there. I'm not aware of any like specific Docker integration with Helm. So Helm, for the most part, just talks to the Kubernetes APIs, and so so we don't have a fork or anything that's different. We just if you look at the instructions for Helm, there's different ways of securing tiller, and one of the options that they say is to just run tiller client side, and so that's what we're doing. It's really ridiculously simple. What we're doing, I'll show it to you here because it's just really a shell script. We launch a pod that just runs a shell script. It's in this weirdly named repo called Clipper Helm. But so basically, we first up here we launch tiller, set the Helm host to run on localhost. Then we just run Helm init, then repo, and then update, and then eventually down here we'll run upgrade or install depending on what needs to happen. So that's it. It's a 55-line shell script. It's all standard stuff. There's no fork. We just download the binaries and package them into the image. You can see that in the Docker file here. Package Docker file. So we just download Helm and just put it into an empty Alpine container. That's it.
Cool. So there was a question about if Linux-Kit would work, but given that it doesn't have a system D, you want to talk to that?
What was that? I don't know what was
the question was. I think this is more of a statement. I think Linux-Kit should work, but there is no system D.
Oh, Linux-Kit. Yeah, Linux-Kit should work. Yeah. So we don't require system D. It's just most systems have system D, so it's very easy. For Linux-Kit, what you should do is run it in a container, and so that's going to look a lot more like I'll show you. So Rancher OS is something. That's our Linux distribution that's very similar to Linux-Kit. It's kind of in the same realm. And so I can show you there's an issue. We haven't piped. Okay, let's see. So what you're going to want to do is, this is the configuration for Rancher OS. Linux-Kit is going to be very similar. So in Linux-Kit, you can set up a service and just set up the volumes and everything. So, I'm assuming you're already familiar with Linux Kit and how to kind of build your own images. And so just kind of follow this as like a reference. It should work pretty well.
Awesome. There's a question from Alexei, and he said, um, it sounds like it wouldn't be logical to convert an existing Kubernetes cluster to K3s, or it might be difficult. Is there anything we've done to kind of look at how, like, sort of analyzing a Kubernetes cluster, just a traditional K8s cluster, and sort of identifying what the gaps might be between sort of taking something and moving it over? I guess the concern would be about maybe some older alpha or beta features that would be underused, or something like APIs that we've pulled out. So do you want to kind of talk about that?
No, we don't. We don't have anything that would like look for like things that might not work. I mean, so far, I mean, we haven't had people yet reporting issues of like, you deleted an API that we're still using. Because again, we tried to just remove things that were not, we didn't see were actually, got traction at all. So we don't really have any kind of utilities or anything around that. I mean, I think we do probably need to do a better job of documenting exactly what was removed. We do have very like well organized patches. I'll show you where that is. Let's see if my Kubernetes GitHub will load here. It's going quite slow. In the k3s repo, there's branches for each Kubernetes release that we do. There we go. So you can see here's like, this is the Kubernetes for 1.3.14. And then if you go to commits, you'll see all of the patches that we maintain. Let me go back. So you start getting, so you'll start seeing the things. These are all the features that we remove. I think I said there's like maybe like 100 patches or something like that. But yeah, so this is where we start getting to the alpha, like storage v1 alpha 1, RBAC v1 alpha 1, some of these authorization or mission registration. So those are some of the APIs that we've removed. So that's the only place we have, I guess, where you can see what's been removed, but we probably need to actually just document that of what things have been removed that you might run into issues.
Okay. Les asked, is there any way to get the node token remotely?
No, there isn't. I mean, I think that ends up being like a security thing of being able to download that remotely. So the best way if you want to get it would basically just to be SCP. It's at a known location, so you could just copy that. If you have SSH access, you could just SCP it out. Before, what I was saying is if automation of bringing up a cluster ends up being hard, then you can use the cluster secret approach, which is you just generate. I think that's in the Docker Compose. I think we use that as the example there. Of you just put a well-known. I mean, so you just generate some random string. It can be whatever you want. So here we launch the server here with the cluster secret, and then when you launch the agent, you give it the same secret. So that makes it really easy to automate.
Cool. Espen asked if we were exposing the traffic dashboard or not. Is there a way to get there?
No, not by default. So if you want to fool with that, like you need to end up. So when we deploy traffic, let me find the. We just deploy this file here. You need to tweak the settings on the Helm chart. So if you go to the traffic for their documentation on their Helm chart, you can flip it on. It's really, I think it's just dashboard.enabled true. And then that will deploy the dashboard, and then it sets it up under some host name like traffic.example.com or something like that. So it's possible to turn it on, but it's not on by default. I think that's like a security issue if it's on by default.
Vladimir asked, are there any features planned for internal Helm/manifest controller, like local charts support, local values files, order of execution, things like that?
So yeah, so we're definitely doing, so like right now there's support for, you can set the parameters, you can also set a values. So you should be able to, like right now through the Helm chart thing, you can get to most arguments. But we need support for private repos. That's been asked by the community, and then offline, so that you can just basically package the entire chart. And so that's what we need to start doing, is basically just put in pretty much just like the whole tarball. So you don't have to actually go out to a repo. You just put the tarball and it'll deploy. And so I think that's what we're going to end up doing for traffic to make it so it works offline, is we're just going to package the Helm chart tarball. So yeah, that feature you should see pretty soon, because that's been a pretty high request, is for like full offline support. In terms of like dependency management, like ordering, we don't really have anything planned there. But we will probably look at doing auto upgrading Helm charts. So you can just set to like have it check the repo and then do an update.
Awesome. So there was a couple questions that were like, kind of about how, if I have one K8s environment and a K3 environment, can the K3s agent join a K8s cluster? I assume it's no, but I wouldn't.
No, not really. So the agent won't. So what we were saying is we're trying to make it so that you can just use the hypercube if you wanted, like it's just a smaller version of Kubernetes, but it's not going to be any easier to run. You'll still have to do all the same, manage the certificates and all the arguments and configuration of the kubelet. So it won't be any easier to run. So for the most part, like the K3s, yeah, it's like the server and agent, you should probably just assume they're tied together, that they won't mix with just a vanilla Kubernetes cluster.
Awesome. There's a couple questions about the size of a K3s cluster. William said, how large of a cluster would make sense to run with K3s? How many worker nodes? Is the SQLite the limiting factor?
We honestly don't know. We haven't really pushed it super hard because that wasn't like our intention. But this question has come up, so I think we'll try and see where it falls over. In theory, SQLite should perform better than etcd. So in all actuality, like, because it's just an in-memory database, and in theory, we should actually be able to scale it higher than etcd. But we haven't actually tried that. So I think we'll try and see, like the intention for K3s was we just wanted to support clusters of hundreds of nodes, not thousands, but I actually see no technical reason why thousands wouldn't work. But we'll go through and test it. So the only scaling limitation of K3s right now is the SQLite, but in theory it should be faster than etcd.
There was a question from Adrian. He asked if multi-scheduler support was there. He's not sure as everything is wrapped in a server.
Yeah, I mean, so the standard Kubernetes scheduling stuff should work fine with, like, so we deploy the kube scheduler. So all the functionality that you get out of the Kubernetes scheduler is there. I guess maybe if there's some arguments to tweak the behavior, those aren't currently exposed, but we're going to end up exposing every single Kubernetes argument as just kind of like a generic hook where you can just set any argument. And then you can always bring in external schedulers using the normal, like, setting the scheduler name on a pod spec. So that that will continue to work if you have external schedulers.
Awesome. Andreas asked if swap is supported or is still not supported, actually.
Yeah, so we automatically set that flag of like is it fail on swap or something like that? We automatically set it so it doesn't fail on swap. So if you have swap on your nodes, it will launch fine. I've never quite agreed with that setting. It has to do with scheduling and eviction and memory contention and blah blah. There's a very good technical reason of why Kubernetes doesn't support swap, but it's a use case that is not super common. Um, so yeah, we flip it off by default. We kind of think that the majority of people actually have swap. Um, yeah. So yeah, it's supported. Swap works.
Okay. James asked kind of an interesting question. He said, could a single K3s cluster be managed by more than one Rancher 2.2 instances simultaneously?
No, that's like just a Rancher limitation. You can only have Rancher, like, because there's basically when you deploy the Rancher agent, you can only have one Rancher agent in the cluster, so it can only be managed by one Rancher server. So that's just a Rancher limitation. Rancher Edge, like, I mean, so like when we do the fleet management stuff, that limitation probably won't exist. That one will be done slightly different.
Okay. There was another question from Brandon. He said, where is the Helm chart controller code? Can that be pulled out as a separate tool / product?
Yeah, so currently it's just in k3s. There's a package. Let's see if you go here, package Helm. This is the controller code. It's built on our controller framework that we use internally at Rancher called Norman. We'll probably pull it out. The other one we were looking at pulling out is the host port service load balancer, which is a controller. But right now it's embedded in K3s, but I think we'll probably just pull them out into separate projects. I mean, if you're just looking for Helm management, I think like Weave has some projects in that realm. There's a couple people who've done similar controllers to manage Helm. But yeah, I think we'll end up pulling it out.
Cool. There's a couple questions. Rick was asking, he said, you talked about a lot of things here, but can you give a couple of real world examples for K3s on a Pi, for example? Let's say got 2 GB of RAM and limited storage. What's the real world application for this stuff?
Yeah, so I mean, honestly, a lot of people are interested in Raspberry Pis as just kind of like a fun thing. But the real world ones that I've actually seen is running there's these new devices that you can get. I think Intel makes one and Google makes one that give you an AI chip to run like TensorFlow or special AI stuff. So one of the real use cases is basically because the majority of the processing is done on these USB boards that they plug in or whatever, and so they just run a Raspberry Pi with these AI chips, and then they can run those at the edge. Because the reason for that is you just can't get the data back to the cloud fast enough. So in order for people to do like fancy image processing and all this computing type stuff, there's just not good bandwidth. Like they have to like send the sampled images or downgraded or whatever, so they can do all this AI processing at the edge, and that's just for like monitoring stuff, like doing something like monitoring your like if you have like some like workers or something, and you want to see the efficiency of what's going on. Like, so we've seen use cases around that. Another one is kiosk type devices, like you see these TVs that are running ads or displays or simple applications. That one's super common, where they just basically take a Raspberry Pi and just tape it to the back of a TV and run some type of marketing media type thing. So yeah, those are some of the use cases there.
There was another question about Istio support for ARM. Do you have any plans to, any idea about what the status is of Istio working on ARM, and any plans to work on that? Is it something on the roadmap?
Yeah. So I don't actually know the status of Istio on ARM, but we do have a stake in the game in that we have a separate like Rancher project coming out in a couple months around service mesh and Istio and whatnot, and that will be running on ARM. So to be perfectly honest, I didn't know that there was specific issues, but I can't now remember if I've actually ran it on ARM. But yeah, so we'll if there aren't images there, then we'll kind of help the community in getting ARM images. But I believe it should be pretty straightforward.
There's a couple questions about storage, maybe like 4 or 5 questions back from about an hour ago. So, but it looks like everyone's still here. Jeroen, Waleed, Alexi, Zach all asked questions. The first one was, have you done any testing on stateful apps with K3s or only stateless ones? Another one is considering to extend the local path storage to incorporate local volume driver instead of host path. Can I use a shared file system like NFS mounts, this K3s storage? Done anything with Minio or tried that? So bunch of questions. I don't know if you want to try and bundle those up. Talk about how storage works.
Yeah, so we haven't done anything specifically around storage in terms of like making it better or making it worse. So it's going to be what Kubernetes currently offers, which means there's a huge amount of storage drivers and solutions that are all available, and you shouldn't have any problem at all running them on K3s. So, whatever solutions, iSCSI, NFS, Rook, things like that should all work fine. We were looking and seeing if we could do something interesting with EdgeFS. So, I mean, it's all available. So all I was saying was that like with K3s, we don't have an out of the box storage solution right now. And we were going to just probably put in the local path provisioner just so something works, so that, at least if you had an application that had a PVC in it, it would provision. Because like we've gotten issues in the community where people will say like, hey, PVCs don't work. And it's like, well, you just haven't configured a storage class because we don't have one by default. But the local path provisioner is not, that's not a great solution because it just creates storage locally. It won't, move it across nodes or back it up or copy it or whatever. And so there's all that. So we have our own project, Longhorn, which is our own distributed storage system too. That works, that will work with K3s. I don't think Longhorn is on ARM yet though, but it is on Intel. So the short of it is the storage, in K3s works as well as it does in Kubernetes. So there's nothing like specifically different in K3s.
Another question, Vicente said, can K3s support HPA in something like Azure container instances or pod native load balancer like GCP with native IP? I don't know if that is enough information for you, but you want to try and answer that?
Yeah, I mean, so again, it's just a Kubernetes. You can tack on whatever additional things. So HPA will work. Well, actually, so HPA will work if you're using the Heapster approach. If you're using Kubernetes metrics, the Kubernetes metrics are currently broken because we're not turning on kube aggregation. That's just on our to-do list of getting kube aggregation, the certificates and stuff set up. So once we have that, then HPA will work fine through using the Kubernetes metrics. things like ACI, the Azure container instances, those things can work as long as you're going like the virtual kubelet route. Virtual kubelet will work with K3s, so you can run that. Um, I don't know what the Google one was, but basically, kind of the short of it is we're trying to make K3s as much as possible just a regular Kubernetes. So like if it works with Kubernetes, it works with K3s. K3s should just be smaller and simpler than the kind of the full upstream thing. Um, so if you have some use case and you can't get it to work, then just put it in an issue. We're trying as quick as possible to handle these things. The amount of traffic that's since we've launched this in the last couple of weeks has been huge. It's quite amazing. But we're doing our best to kind of prioritize and handle the requests and fix everything so that all these use cases that will work, or all these use cases can work.
Okay. All right, maybe we can. I mean, there's still quite a few questions. A couple more. Let's try if we can go. Espen asks, how can I get my own certificates into the traffic on K3s?
Oh, so yeah, I mentioned before that there's that it's all deployed through the Helm chart, so you're gonna have to tweak the parameters on the Helm chart, and then probably put your certificates into put your certificates into a secret. So that one I don't know the direct answer. But basically, you're gonna have to look at the traffic documentation and their Helm chart documentation on how to get things in. I know for certificate management in general, Cert Manager ends up being a really nice solution, which will help you either get certificates for somewhere else, or you can put in your own CA or deal with an external CA. So Cert Manager from JetStack is a great solution for managing a lot of certificates in Kubernetes. But anyway, so I don't have a direct hand. I can just kind of point you to look at the way we're configuring traffic through the Helm chart and then kind of refer to their documentation.
Okay. Another question is, Laurent, he asked, besides port 6443, what other ports are used? It's kind of similar. Alexi asked, since a different proxy component is used, is it still possible to get customers real IP addresses in containers with K3s implementation of Flannel and Tunnel Proxy? And there's a couple questions like, is Tunnel Proxy definitely required? Do you want to just talk about those?
Yeah, so the tunnel proxy right now is definitely required. It's kind of hardwired if that's the communication. That has to do the control path communication, not the data plane of pods talking to each other. So it doesn't impact any behavior around networking, pod communication, IPs, masquerading, none of that changes. So if it worked in Kubernetes, then it will still work in K3s. If it didn't work there, it's not going to work in K3s either. So nothing really changes for the pod communication. It's just for control plane components. For the okay, shoot, I forgot the rest of the question.
I think the rest I actually already sort of responded to it, but there's actually another question that kind of gets into this. Can masters? It was like I think who was asking about port 6443.
Oh, right. Let me bring up. So the networking requirements is from a server node, 6443 needs to be exposed to the worker nodes and whatever clients, whoever's talking to it. Like if you want to run kubectl, then you need to be able to get access to 6443. So that's the main port for the server. For the nodes, the VXLAN port has to be open to all other nodes, which is 4789. Now, I want to put a special caveat here, is that VXLAN by default, actually VXLAN in general, you have to put like some type of perimeter security around that. Like you have to firewall 4789 externally, otherwise it's open to the world. So like if you're using a security group or a VLAN or something like that, make sure you protect port 4789. We're looking to try to figure out if we can find some like put into K3s some networking that's encrypted by default. There's a couple options. We're still investigating that, but right now we use VXLAN. So those are the only two ports you need to really worry about. Is 4789 on the nodes and 6443 on the servers. And 4789, make sure that port is protected because there's no authentication on it. If it's open to the world, then somebody can just inject traffic into your cluster.
Tom had an interesting question. He said, can masters and agents discover each other with zero conf or gossip or something? And if not, is that something you're working on?
That's what we're working on for the HA solution. So the HA solution is going to be based off of gossip, and that's how we'll do node discovery and deal with node failures. So, for example, in Kubernetes today, if a node does not check in, it just goes into like a not ready, like unavailable state. But Kubernetes doesn't actually know what to do with it because it's like, well, it just hasn't checked in. So the default behavior is to go to the cloud provider and then ask the cloud provider if that node exists. If it doesn't, then it can delete the nodes and start doing things like moving stateful sets around. But in a K3s doesn't have a cloud provider, so we don't have that ability to go to the next level. And so basically we're going to be using gossip to kind of do that next level of like, well, is the node really there? Well, if gossip can't find it, if nobody can ping it, then we'll say it's gone. So we will be doing that. So that's how we're going to end up doing the HA solution. And so for HA, basically what it is it's going to be using gossip to form the kind of the loose cluster membership. And then once we have that cluster membership, then to start up etcd or start managing the etcd masters. And like if one of those dies, then replace it with another. So we're doing kind of some of the etcd management, so you can get highly available control plane state.
Awesome. All right, we're gonna probably wrap it up. I think we got two more questions, but we're just way over time. Alexi asked if you recommended running an external etcd control plane now, or is the control plane just so tiny it doesn't really require the overhead of managing additional nodes? I'm assuming that the answer.
Yeah, so we're if you want to run an external etcd, then we're kind of just saying you should probably just go to a regular Kubernetes distribution. So when we first started, we're like, well, we won't, like, we had the standalone, what we have today, and the standalone works really well, like just a simple single master, and you can automate it and do a pretty good resilient setup. So then we were saying like, oh, well, we'll just allow people to spin up their own etcd, and that's how HA will work. But then we realized, well, that's actually significantly more difficult than most people think, because it's not just about putting a highly available etcd. You also need multiple API servers. If you've got multiple API servers, you need a load balancer. If you have a load balancer, how are you managing the certificates for the load balancer? So it just gets more complicated, and so that's why we really just prefer to do a kind of an all-in-one. We'll embed the etcd into the control plane, and we're going to use gossip to do the cluster discovery, and then use client-side load balancing to remove that, and then do all the certificate management. So we can make the HA setup just really nice and easy. If you want to do it manually, then we would just say, go run like RKE. That's our other our kind of full industrial weight Kubernetes. So you can just run RKE. It's really not that difficult.
Awesome. There was one last one. Dominic said, just kind of a question about service mesh we were talking about a minute ago. He mentioned that he'd seen a post from you earlier, mentioning you thought Linkerd was a lot easier to wrap your head around than Istio. Anything you can kind of elaborate on that, and why
sure.
think about Istio so much? What's changing, and is there a killer feature in Istio that kind of seems to be causing people to talk about it so much more than Linkerd? And also the fact that he mentioned that in the Rancher catalog we've got Istio but not Linkerd. Just a feeling at the moment of if Linkerd and Istio are competitive offerings, what's the direction the market's going in? Do you still kind of feel like there's a lot of a strong case for Linkerd over Istio? Maybe just an update on that.
Sure, yeah. So it's a little bit off topic, but I'll answer the question. Yeah, because this is something I've done quite a bit of work in and used service mesh quite a bit. So the reality with service mesh is it's still very early. There's not like massive adoption of service mesh quite yet. So people are still, looking at it and starting to adopt it. So there's like not like a clear winner or something of like this one's better, like, this one has real adoption or market. So Istio in general has significant more marketing. And so I think in general, that's why it's talked about a lot more. People just hear about it a lot more. And it comes from, some major companies like Google and like who else worked on it? IBM is pretty actively involved, and Envoy is from Lyft. But anyways, these two projects are really quite different in their approach. Linkerd is really oriented towards the user in a very practical use case. They're saying, okay, users are coming into service mesh. What do they really, really, really need? How do we make that work really easily for users? And so Linkerd is just super easy to run. It gives you the primary use case most people care about up front, which is monitoring and visibility. So that's why I really like Linkerd. It's really easy to install, and it just gets you going. Now, Istio kind of takes a completely different approach. It's more of the Kubernetes style of like, let me give you a bunch of primitives and various components, and then you can kind of assemble a solution. So Istio, I'm kind of convinced, is not really designed to be directly used by a user. So if you're building, let's say, like a Knative application framework, like something like that Rancher would do, or Pivotal or something like that, then your Istio ends up being really good because it's a very generic primitives and components that you can kind of tweak and pull together to do a service mesh. And so Istio has pretty much every piece of functionality. It's very, like, they have tons of features. It's just extremely difficult to use because, again, I don't know that it's like really oriented towards the end user. It's more like components and primitives and stuff like that. So they're really quite different projects. And so I think there's kind of, we'll see as Linkerd matures and as the space matures and more people are really putting this in production, how it pans out. But like if you're building a framework and you need service mesh functionality, Istio is kind of the go-to. If you're an end user and you just want something that's simple, then Linkerd is definitely the simplest thing to run.
Darren, the last question, I keep saying that, but Adam asked a good one. He said, what was the most resource-eating feature in Kubernetes that's removed in K3s?
Oh, that's a good question. I think so. In terms of like just memory footprint, so removing code ends up being like what removes a lot of the memory. And so like the biggest thing was really the cloud providers, because the cloud providers depend on the cloud provider SDKs, which are massive, like the Amazon SDK or the Microsoft Azure SDK. Those are just huge components. So there's just removing a lot of the code dependencies ended up taking out quite a bit. So I think that was probably one of the biggest ones. One of the, not the biggest, but the surprisingly heavyweight things is the way OpenAPI is handled. So we tweaked the way OpenAPI works. We're still trying to improve it, but OpenAPI in general there's a lot of code around that. It's ridiculous. A lot of processing, a lot of code, a lot of memory just for OpenAPI. So we're trying to figure out what can be done to improve that.
All right. Well, with that, I think we're going to wrap up today's online meetup. Thank you to Darren for spending so much time demoing and working on K3s. Thanks everyone for coming and for all your great questions. We're going to be posting the recording soon, as well as all the slides and everything. But with that, I hope everyone has a great day, and we will see you hopefully next week for our meetup on Submariner. I remember that's at submariner.io if you need information. Have a great one. Bye bye.
Bye.